Good morning, and thank you for joining today's webinar, Myth-Busting 2D Vision for Robotics. My name is Eric Trower, and I'm a member of the marketing team at SICK. SICK is the leading provider of sensor solutions. Today, we welcome Ryan Guthrie, Executive Vice President for TM Robotics, Nick Longworth, Market Product Manager at SICK, and Brian Sellers, Industry Marketing Manager at SICK. The team is streaming to us live today from Shibuya Machines' North American headquarters near Chicago in order to provide us with a firsthand look at Shibuya's SCARA and 6-axis robots. So I'd like to take a few minutes here just to go over a few points regarding the WebEx platform that we're using today. In order to optimize your view of today's presentation, I'd ask that you please locate the layout button in the upper right-hand corner of your screen. Click on Grid Layout, then Hide Participants Without Video. This will provide you with a full view of our presenters. If you have any questions during the presentation, please type them into the chat box in your WebEx control panel on the right-hand side of the screen. Following the presentation, we'll take time to address as many questions as time allows. And lastly, I'd like to mention that a recording of this webinar will be emailed to you. With that said, I'd like to pass the ball over to our speakers, Brian, Nick, and Ryan.
Well, thank you so much, Eric, and good morning, everybody. You've almost made it through another week. Happy Thursday, Friday Eve. We're getting there, folks. We're getting there, but thank you for taking some time with us this morning to join us at this awesome facility at Shibuya Machine here in the Chicago area. Just want to again, thank everyone for joining us. You can see some information on the screen that is going to optimize the viewing pleasure for you guys and to see these incredibly handsome gentlemen we've got here today to speak to us about robotics. And so we want to thank these two again for taking the time. And again, thank you for joining us as well. So I guess I just kind of wanted to start at number one, Ryan and Nick, could you please just kind of say hello and tell everybody who you are?
Yeah, I'm Nick Longworth. I'm from SICK. I've been with SICK for about going on 4 years now. I really work with most of our robot guidance equipment, anything robotics really. And prior to SICK, I was with an end user for about 10 years, focused on assembly, welding, machine tending robotics, a little bit of everything. So I've been around the block a few times in terms of robotic applications and how everything works.
And as Eric said, my name is Ryan Guthrie. I'm Executive Vice President and Technical and Application Support Manager here for TM Robotics. We are the master distributor for Shibuya Machines industrial robot product for all territories outside of Asia. I've been with the company for about 15 years now, primarily in the technical roles. So looking forward to sharing some of that knowledge with everybody here today, live from our beautiful facility here in Elk Grove Village outside of Chicago.
Wonderful. Well, thank you so much. I appreciate it, guys. Thanks again. Now, again, y'all are the show here. Y'all are the stars. So I want to make sure that we concentrate on you guys. I've heard y'all use this term VGR, and I think it's called Vision Guided Robotics. I'm just wondering, like, Nick, could you kind of talk about that a little bit more and maybe talk about like the industries and the applications where it's used?
Yeah, so you're correct when you say VGR is Vision Guided Robotics. It's basically taking a camera and creating the ability for the robot to understand essentially the data the camera is providing. So taking an image, finding something in that image, and then telling the robot how to actually go and get it. And so there's a lot of math behind that. There's a lot of different pieces to that can either be complicated or easy, depending on how you set something up. You can do it in just a static 2D. It can be a dynamic 2D, like conveyor tracking, where you're finding an item in a single layer. You can get into 3D, where we might be doing multiple layers, like a depalletizing or possibly bin picking or anything like that. So there's a lot that you can get into, different things that it's capable of, and we'll certainly go deeper into that today.
Cool, excellent. Yeah, and you mentioned the static 2D being one of the ones we're talking about, and that's really what we're concentrating on today. So no, that's great. Well, let's get into these myths. So we've got our own Mythbusters. They don't quite look like the guys from California, but we'll trust that they have the same level of expertise, and I think after this this webinar today, you guys will agree they do. All right, so here's my first myth, y'all. All right, here we go. Robot companies, a lot of those manufacturers out there will actually offer their own 2D vision solution that's integrated into the robot. All right. So you buy the robot and it's coming with the camera. That's the best thing you can do because they've already done the integration for you. So that's the myth. You buy it from them, you get their system. It's going to be a lot easier for you. And so that's the myth. So Ryan, I'm going to let you answer first. What would you say to that?
I would say it is a myth. Robot companies are not vision companies, and vision companies aren't robot companies. So everybody's got their specialities and their focus and their core competencies. And you need to make sure you're balancing that. They may have an integrated solution, but is it really the best solution for your integration? So being able to be flexible and being able to use different manufacturers, mixing and matching, has its benefits.
Yeah, and so when I look at a question like that in a myth, basically the real question here is, how does the vision system interact with the robot? And when you say it's integrated into the robot, normally that just means that maybe you can configure it on the teach pendant, right? I mean, that's really all you're talking about. And how many people really want to configure a vision system on a teach pendant? That might be difficult. It might be hard to use, but I mean, that's one thing to look at is, how does the vision system actually set up on the robot? So for Shibura, what does that look like in terms of actually getting a vision system into the robot itself?
Yeah, so the interesting thing with vision and robotics really is, at the end of the day, all the camera is doing is sending a few coordinates to the robot. That's all it's actually doing. So we talk about integration, we talk about making it seamless for that setup, but the setup process, at the end of the day, you're going to do it once ever for the system, ideally, and all you're doing then is sending some coordinates back and forth. So from a robot perspective, it's just setting up communications, and in most cases, it's a case of putting in an IP address, checking your port number, and hitting play. So from us, it's a pretty straightforward integration process, regardless of the integrator.
Yeah, exactly. And so when you start talking about having something that, is integrated into the robot, and again, that's a term that we're saying here, I don't feel it's a complete, necessary thing to be a good vision system. I think you can do a lot of different things with a robot with any vision system. So
Cool. All right. Sounds good to me. Yeah, that works for me. All right. Well, let's go on to another myth then. I think we've addressed that one. So I've got another one here. And again, these aren't my myths. These are just common myths out in the industry, that any kind of robot needs a dedicated robot specialist. Any robot needs a Ryan, and every vision system needs a Nick. We need a certified, dedicated vision specialist. If I'm going to use this at my facility, I've got to have these two people at my place. So Ryan, what would you say to that?
I would say robots are not a new technology. It's a very mature market. Most industrial robot manufacturers have refined their process. They know what they're doing. Shibura machine is no exception. We've been building robots for 40 years. So it's no longer a case where you have to be a specialized engineer to understand and work with the interfaces. They've really made user interaction as painless as possible. And you can pick it up real quickly. I mean, from the training that I've been doing over the last 15 years, a lot of the feedback we get is people are really impressed with the lack of a steep learning curve. It's something that in a few hours, they're programming robots, making things move, and doing an application. So everything's been designed so a lay person can pick it up, and they don't need to have a coding background to program a robot. You don't need to understand kinematics to program a robot. The beauty of robot technology is that's all done in the background. You don't have to think about that. All you need to say is go to point A, go to point B, turn on an input, turn off an output. That's about it.
Yeah, on the vision side, it's gotten very similar. I mean, I think you mentioned low code, right? I mean, low code, no code. That's where everything's going in the industry. And when you looked 20 years ago, and it'd be interesting to get your thoughts on basically what robots looked like at that time as well. But vision 20 years ago, you had an external controller, you had a camera that comes on a wire back to that, and you probably have to program it in, I don't know, back then, maybe Pascal or maybe some kind of C-based language that would actually do the processing and work with the robot. Now you're talking about embedded controllers in a smart camera, and web server interfaces that are able to really simplify all the stuff into a low code, no code platform that really it's a configurable device. It's no longer a programmable device that you really have to jump into. It's even the architectures have changed where again you're not having to have an external controller. It's just something where you run a single Ethernet line back to it. I mean, what are the big differences on the vision side from the robot integration on that piece of it?
Again, it's because the vision technology has advanced so much, it's actually made it even easier on the robot side over the years as well, because we are no longer having to worry about we're probably going to touch on this in a little bit. I don't want to jump ahead of ourselves too much, but the calibration and people previously you had to do a lot of math on pixels to millimeter and how do you convert all of that. And a lot of that had to be hand done and hand coded into not only the robot, but then you had to share that information with vision and back and forth. And there was a lot of, well, how did you do this? So I do it the same way. And the vision systems today have really simplified that. It's a drop-down menu. It's all right, boom, this is the robot I'm using. This is the coordinate system. Calibration takes seconds and we're done.
Yeah, and from a SICK side of things, what we're really talking about is our Plot 2D platform. Plot 2D is our 2D guidance system. It's what we use in any kind of 2D application. Can we share the screen?
Yeah.
That really shows this?
Yep.
Is that this one?
Yep, ready to go.
So this is the interface that we're talking about. And again, this is something that's been developed over years and years of just R&D, research, that kind of stuff. And so this is all web server on this device. And it really shows the simplicity that we're talking about here that this has become. It's not something where I'm going in and I'm having to specifically code anything or even set up a tool tree anymore. I'm not even setting up something where maybe I'm having to filter the image and then maybe find this piece, then mask, then figure out my communication. This is all just basically a 1, 2, 3 setup coming down this sidebar here. So typically, just to walk everyone through what this looks like, generally you start an installation and we work our way down. So installations where we might take an image, and right now we got the robot in the way, but you got the idea that we can take an image pretty easily.
This one will be.
Oh yeah, we can do this one. Okay,
yeah.
Here we go. So yeah, we go to this other camera here. Do the same thing though, and we can take an image. We can start seeing exactly what the camera's seeing. And we can do things like turning on an aiming laser so we can place the camera easily. We're not sitting here, move the camera, take an image, see if it's where we want, move it again. You just turn this on and the crosshairs are what you line up. The camera helps you focus it correctly. If you turn on the focus adjustment, it tells you what a good focus is. And then you can come down, you can calibrate the lens. And what lens calibration does is essentially what's happening here is the system is determining what the deformation of the lens is. So it only has something to do with the camera lens. We're just determining what that fisheye effect is so we can get rid of it. And you show just show a grid in a few different orientations here. And once you're done, it's ready to go. You calculate it and the system figures it out for you. You don't have to do much else from there. And then alignment's the next step. This is where we actually jump in with the robot. And Ryan mentioned the millimeter to pixel, pixel to millimeter translation. That's what's happening here. And along with that, though, where we're basically understanding this grid and we know this grid that's already in the device and we measure it and that tells us how many pixels make up a millimeter. But at the same time, this device is also going to warp and rectify the image. So if you've mounted the device at a tilt, we automatically flatten that image so that you're able to use this effectively. You don't have to do any of that in the background. It's all done automatically here. And then after that, you set up your job, which job is extremely simple, where we would just essentially take an image. If I run through one right here.
Duckhead.
Go duckhead?
Yep.
Okay. Go duckhead.
That's the one that, yep.
Take an acquisition. Maybe we set up our brightness and contrast a little differently because you can see this is pretty dark. So maybe I throw this at 70. Maybe I turn my contrast to 10. Oh, and that's going to control my exposure, time, and gain, which for anybody who's newer to this, exposure is basically how long my my camera sensor is collecting light. Along with my gain is how much I intensify that light. So there's different things I can do there. in terms of getting a brighter image. That's essentially what's happening is I'm looking to get a brighter image, and maybe I even go brighter on this one than what we have here. And once you have a decent image, then you're just literally going to brush. The device doesn't have any tool trees anymore. Again, it's low code. It doesn't have anything you really have to set up. I just take my part shape. I say, okay, let's go find this area here. The device does a little bit of thinking, and it comes back and tells me, hey, there's a pattern here. You can see these different lines, and that's what I'm gonna go out in the image and find. And even more so, now, instead of having some of the older ways that the robots worked with the vision system is where you maybe take a teach point on the robot and then you apply an offset from the vision system. Now you can actually do your teach point here. And I can actually just drag this over here and tell my robot, hey, I want you to go pick like this. This is how you're going to actually pick this part. And just moving this around, this is my teach point. I mean, what does that do for customers and applications having features, something like that?
Yeah, so the teach point, like this, what we're showing here, it simplifies the robot part so much more because now, again, we don't have to worry about part orientation. We're controlling that in a graphical interface. We can see this is the rotation the part is going to be. This is the pattern that we've identified that we're going to be picking. The example that we actually have here for later on is the duck head itself. So when I pick the duck head, I want to make sure that the duck is looking forward when I place it down. Right. So I make sure I orientate my grid like that, and we're done.
Yeah, that makes it so much easier than, again, some of the older ways where I might have to bring in the robot and I'm going and touching off on the duck head and saying that's my reference part, and I need to take an image of that same exact scene, and now anything that moves I apply to that point on the robot. It works, but it means that your support is now on the teach pendant and in this user interface. Now with something like this where we've gotten into this low code environment, all your stuff's right here. It's all right in front of you in one interface, and you can just change it all, and your robot program is never touched, which is great from a supportability point of view, I believe.
Absolutely. One of the other things that we were talking about before the webinar today that's really nice with this job feature as well is right in the camera interface is where we can do Z offsets. So we're looking at approaching for parts, or if we've got to compensate for the height of a part, maybe we've got different variants or things like that. There's options where the end user, the operator for the machine, can come to a very comfortable graphical interface. You can change different service levels up here on who's actually operating the machine so that they can lock out certain parameters, but it allows an operator to come and go up. Today, the part seems to be sitting a little different, or the gripper on the robot happens to be bent because somebody on third shift crashed it. So they can do quick calibrations without having to get an engineer out to the field to change the vision, to change the robot program. They've got a nice, easy interface to do it with.
And so I do think the answer to this myth, a little bit more where, you need dedicated specialists for both of these sides. I think having these low code platforms that are kind of inclusive of all these different pieces that are needed for the robot and for the vision side, I think that gets you to the point where you don't need the vision professional because you're dealing with something like this. If that makes sense, what I'm saying.
Absolutely. Yeah. Absolutely.
So
cool. All right. Well, I want to go from that because Nick, there was something you mentioned that actually brings up our next myth is about lighting. And it seems like the myth is for 2D applications, any kind of vision application, I need some sort of mega expensive, heavy duty light. I need a third party light. I need to do all these funky things with different lights. So, Nick, if you think that's the myth, what would you say to that? If you heard that was the myth, what would you say?
So lighting is definitely the determining factor of the success of a 2D vision application. And the reason for that is we're working with contrast. So you can see, if we're still sharing the screen here, you can see what we're looking for is contrast. We're looking for that light to dark transition, and that's how we actually build the pattern that we're going to find. And so if you have issues with your lighting where you're not getting those contrast transitions, and they don't have to be white to black, they can be, somewhat dark to somewhat light, or even sometimes, neutral to somewhat light or something like that. if you're not getting those transitions, you're going to struggle to find a valid pattern that really effectively and robustly solves your application. So lighting is definitely the determining factor, but I don't know that I'd say it's an expensive factor.
You had made an interesting comment to me as well when we were prepping for this, that what we see on screen might make logical sense to the human brain, but the vision system doesn't need to see it as clear as we see it. So you were talking about like a dark image when we were talking about some of the teaching jobs and things like that. I was surprised how when I'm looking at the screen, I don't really see anything, but the vision system was able to see, it was able to pick up black dots in a dark shadowed area. So, I mean, it was able to do a lot more thinking and processing. It, again, it's all it's looking for is a pixel that might be color 255 versus a pixel that's color 254. That's enough of a transition for the vision to recognize.
It can be, depending on the AI going on in the background. So there is some filtering steps in, say, the Plot 2D device, or if you're using a tool-based device, you can apply those filtering steps. And if those filtering steps are set up right, you can find those different transitions. And it's often that, you know, we say that the image, a good image for a 2D system isn't always what looks like a good image to a human eye. And so there's definitely that piece of it. But going back to the lighting, I mean, there are definitely expensive lighting solutions out there, and sometimes it's required, sometimes it's not. But I can say that the vast majority of applications, the lighting has just continued to go up and up and up, just like the rest of the technology. So the Plot 2D, for instance, comes with a internal light. It comes with a light, ring light in it that does a bright field light. You can see in here.
That on for you. Go for it.
Yep. You can see in here and on the device itself. I don't know if we can get that one shown here. Yeah. Maybe show the one on the right here. Yeah. Where we can really see that there is in fact, you know, in this camera, if I get up here, underneath, you can't really see it, but there's a light ring in here that goes around our lens. And that light ring is built in. It's something that is, you know, it's capable. It works for a good realm of applications. It's kind of like your 80-20 rule. Your simple lighting can probably solve 80% of applications, maybe 70, something like that, where you don't need to get into this expensive lighting solution. And that's just, again, it's the advancements of technology where we are filtering the images, we're applying all these new types of technologies to the image so the lighting doesn't have to be perfect anymore, which is a great, you know, solution there. And the other thing I tell people too, often in my applications engineering, is that 3D vision it's gotten a lot cheaper these days. If we're going into a complex lighting solution for 2D, maybe it's just worth going to 3D. Because in 3D guidance, often it's very robust to ambient light. You're finding shapes in a point cloud. It's an entirely different way of functioning where you don't need the contrast at all.
It almost ignores shadows, essentially.
Exactly, it ignores shadows. So that can also be another solution to a difficult lighting problem where, well, we go to a 3D system that is just as easy to use as this. It's a similar system, but it doesn't have that downfall. Just a little more expensive, but maybe not at all, because the lighting solution would need to be so robust in this case.
And there's things that can be done from the robot integration perspective as well to address lighting.
Yes.
So, for example, if you're building a cell, I mean, if you kind of look at the cell we have here, I've got a lot of open glass and it's got an open top, and we're in a workshop right now that's got great lighting. But if we happen to be in maybe a different manufacturing facility that's got, let's say you've got an east wall full of windows, and the lighting within the working area changes throughout the day, that ambient lighting condition may affect the vision system. So knowing that you've got those conditions, you could build your robot integration with those compensations in mind, having darker Lexan or some sort of darker cell. Again, the robots don't need to have the same working light. The vision doesn't need to have the same working light that humans need. So being able to use something like the Plot 2D that's got the integrated lighting solution on it, you control the rest of the environment. Now you've got a very low cost and effective solution.
Yeah, exactly. And another thing on it too that's just coming to mind here is that kind of the test when you're looking at lighting that you want to apply is have all your lights on in your room, so all the ambient light you can get. Take an image. Turn them all off. Take an image. Those images should look the same. If they don't, or they should be close. They might not look exactly the same, but they should look close in terms of intensities. If they don't, need a better lighting, or you need a better mitigation strategy on it. That's how you check if it is a robust lighting scenario, is do you get the same result regardless of ambient light? And so that's always a good way to look at it from that point of view. Something else, though, I thought of too, from just going back to one of the other myths of having, difficult, it's difficult if it's not integrated. It's difficult without a vision professional. If you do have to do a external lighting solution, a lot of the devices, including the Plock 2D now, have that built in anyway. Our 631 device literally has an external illumination port that can handle up to a 0.7 amp light at 24 volts. You literally just plug the light in and the device manages it for you. You don't have to go strobe it and turn it on or anything. It acts like it's the internal light. And then the rest of the devices also have a separate port that can go back to a relay to run a heavier light if you need a higher amperage. So even if you have to get an external light in a simpler application, it's not even that hard to do anymore, because the device is going to manage all of it for you. So,
well, I'm listening to y'all, and we're talking about just ease of use. You're talking about how much easier these things have gotten to use, and I think that's our next myth, is basically making these cameras work with a third-party robot is time-consuming and tedious. It's just a lot to do. Ryan, I'm listening to you talking, and I mean, you sound like a vision specialist. I told everyone here that you weren't earlier. You sound like one, but I'm going to guess you aren't. But tell me what you know. I mean, tell me, what do you think about this whole idea of this being time-consuming?
Yeah, I think it. I mean, let me give an example. So Nick was kind enough to get me the two cameras in advance of the webinar here. I set both cameras up in an hour yesterday. So it took me longer to find all of my little bits and bobs to make the brackets to mount the cameras than it did to actually calibrate the cameras and set them all up. So I am not. I mean, I've only been working with the SICK equipment now for a few months, and it's been an hour here, an hour there. And already I feel comfortable enough to be able to teach my end users and my customers about the basics of running these cameras. I feel very confident. And in fact, stay tuned for future videos from TM Robotics. But
Awesome.
They are a really, the graphical interface, the browser-based interface that SICK offers made it really, really seamless for me. And obviously Nick has been a great support, kind of helping set everything up as well. But I set it up in an hour. So I felt very comfortable with the equipment.
yeah, and I think that's, again, it just goes back to the power of a low-code interface. And I think that's where everything's going these days. I mean, if you look at any industry that's heavy in technology, low code is just where everything is going, where you don't have to deal with, a whole bunch of tool trees in Vision, or a whole bunch of, on the robot side, having to do the kinematics a long time ago you did, or anything like that kind of stuff. So it's definitely, the ease of use has really come back. And I think it's worth walking through just how the device actually does set up with a robot. So I don't know if you want to walk us through that, Ryan, and we can.
Yeah. So let me prep this screen over here. So
I always like seeing is believing is what I say. So I think it's always worth a good visual here.
Yeah. So as far as the setup goes, so Nick kind of walked through the tree earlier. The calibration, that's the camera and the lens. So once I'm done with that, once I have that part done, from an integration perspective, I can look at my work cell and go, actually, that mount isn't going to work. Where I've got that camera mounted, that probably is not the best place to put it, because I can't approach with a 6-axis robot at the right height or whatever. So I can move that camera now without having to redo the calibration. So that part of it was really nice.
Yep.
The next step from this is, if we transition back over here, the alignment. This is that, how do I get this coordinate system so that the vision and the robot are talking in the same grid, if you will. And the process for this was pretty straightforward as well. So I'll have Nick there. He's got this alignment grid.
Yeah, grid looks like this. And this is basically what you put in front of the robot. So
Yep. So with that grid, all I do is I lay that on the work surface where I'm going to be picking parts from. The vision does its side to do the pixel to millimeter thing. After that's done, I take my robot, I line it up to the center of the grid and say, here's the origin of the grid. Here's my X plus, here's my Y plus. And that then calibrates the robot work side to the vision work side. So now if a part is rotated, sitting on a thing and it's rotated this way, I know which way that duck is facing and I can come and pick it and place it properly wherever I'm placing it.
that's a pretty easy process on the robot side too, I think. Right?
Absolutely. So on the robot side, in our programming language, if I share that screen here, I have a coordinate that I can set up as my SICK frame. And we've actually got a 3-point teaching method for that. So I literally jog the robot to the center of my grid, press teach for the first time, move it in the X plus direction. As long as I move more than 10 millimeters, it recognizes that as a vector. I save that. I move it in the Y plus direction. Again, I only have to do it a few millimeters, teach that, and that ties all the systems together, and the robot now has that frame taught. And we're talking about low code. This is the entire code that runs on, which robot did I pull up here? This is the SCARA robot. So on our 4-axis robot, this is the entirety of the code. This is every line of code that I had to write in order to go pick up a duck that's sitting on that bucket over there. So we're looking at, I mean, if I take out all of my comments and everything else, I've got 10 lines of code. 10 lines of code is all I need to run a vision application.
Right, and it used to be probably hundreds.
Exactly,
at one
exactly.
point in time.
And Ryan, you mentioned earlier too that some of the feedback you've gotten from your customers in the 15 plus years you've been training is that, you know, these Shibura robots seem to be very easy to commission. They're easy. The learning curve is not steep at all. How many, like, we'll just say when you sell one of these, how many weeks does it typically take for someone to learn one of these?
We measure it in hours, not weeks,
What?
to be honest.
Okay.
So when we get new users in, typically for a new user, we include 2 days of free training with their first purchase. And in that 2 days, by the time we're done with the second day, we typically have the skeleton of their program completely written. So the first hour or two is getting our head around syntax. If you kind of look, you'll notice our syntax is very straight. It's human readable. There's not a lot of arguments and things like that. There's not a lot of commas and brackets and things like that that are all over the place. I have commas separating variables. All of my commands are actually words that are in the English language. So you'll find them in a normal dictionary as well as our programming dictionary. So it keeps it a little bit more comfortable for a non-programmer to approach it. Same with the vision. What I like with what you guys do too is the terminology is spelled out. It's not, you don't need to know a bunch of lingo and jargon to be able to program these things. So when I'm working with a customer, like on a vision application like this, you can see in the comments, I've got 4 lines of comments, and that completely explains the entire data string that comes in from the vision. Keep things nice and simple and straightforward.
I mean, really, at the end of the day, the commissioning that used to be a huge time crunch where you're training, you know, I used some older vision systems back in my end user days, which they would take me a day and a half to set up. It's not the case anymore. It's something where technology is just really advanced even in 2D, which if we really think about, you know, the progression, 2D vision came out 30 years ago. You know, people have been using it 30 years. It's an old technology, but it's getting new life just because of how easy it is. It's not as scary as it used to be because you can really, you know, do a lot of things easily now that you couldn't do before.
And I think it's the next progression from robotics as well. So robotics have always, I mean, robots in the modern sense, if you will, have been around since the early 80s, even earlier, 70s. 61, yeah, Unimation. Yeah, exactly.
Yep.
So you look at servo technology, and yeah, there's been changes in mechanical structure. And
the original robot used a drum. It was a drum controller.
Exactly. Yeah. So yeah. So there's been some changes, but they've gotten to a point now where they're more of a commodity than a specialty product. And so now the next logical step is, all right, now I can move something. Now let's see something. Let's give that robot additional senses. Let's give it eyes. So now I can identify parts, which then simplifies overall integration as well.
I mean, yeah, it really opens up a lot of applications there. I mean, what applications do you see that you think this really opens up on your guys' side?
On the 2D side, we're doing a lot of stuff with part feeding and part presentation. So talking about other technologies that have changed, really, you look at bowl feeder technology and feeding technology, part presentation. Now that vision has become easy to get for any integrator. You don't, again, we're talking before, we don't need a specialist for vision anymore. So now you can have a bowl feeder that, instead of doing the whole black art of trying to figure out exactly how to orientate a part, you can get a part close enough, get it into a field of view of a camera, send the coordinates to a robot. The robot's going to come and pick it in a perfect position to drop it into an assembly, to a through hole part for circuit boards, connectors for automotive components. I mean, all of those kind of things become easier when you start adding vision and robots together. It's just becoming much easier to put those type of cells together.
Yeah, it really opens up a lot in terms of not even just capability, but ROI too, because you're talking bowl feeder. Bowl feeders, they're not cheap. You know, they can get expensive real quick depending on what you're trying to solve. And
especially if you've got a high SKU count and low volume,
yeah.
They start to become, so that's where having a more generic system where, okay, you don't need to customize it to this part, customize it to this family of parts, let the vision do some of that calculation. Okay, today it's part A, today it's part B. So the vision can store those multiple jobs and be able to be called up very easily.
Well, it's the hard automation versus the flexible automation question. You know, normally hard automation might run faster, but you need the speed first. And then flexible automation, it's definitely gonna, be able to do more with less money. Normally, that kind of stuff, and ROI a little better.
Talking about different recipes and talking about different things, the vision, with that, right in the data string that comes from the vision, it tells me what model or what job I'm looking at.
That's true.
So with that, in the robot, I can simply take that variable, which way variable is it? J, I think it is, or whatever one it is. I can turn on and say, if this value equals 1, then I know I need to use this tool and go to this drop point. If that value equals 2, I need to go from here to here. So there's a lot of flexibility inherently built into this as well.
That's actually a good point. Just for everyone's knowledge, the Plot 2D actually internally supports sorting, where you can actually tell it to run jobs concurrently, and does that work for you to determine what is out there in the image and where it is, and it tells you what it found at this position, that position, as you go pick it, in order to put it in the correct position. But it does all that automatically. None of that's needed, again, in the robot program. Nothing complicates your robot program. It all stays easy, which again is kind of the theme here. Is all this is so low code and no code now that it really is. It's getting super easy to do a lot of these applications. And the other piece is downtime. When I'm thinking about bowl feeders again, or any conveyors, that kind of stuff. Bowl feeders in a lot of applications, cleaning, repairs. I've heard some people tell me 30%. Expect it to be down. My personal experience is more like 10 or 15, but as somebody said that to me yesterday, for the automotive industry, was 30. But that's a big thing as well, is the downtime of hard automation is a little bit higher than something like this, where if you have downtime, it's still just a software solution. You just pop in the software and it keeps going with the new device. If something happened, which is normally a forklift hit the camera or something.
Yeah,
like
exactly.
It's not normally the camera going down itself.
Those are not necessarily the what ifs that were calculated for when you were building up the project.
Yeah, exactly. Normally the mean time to failure of these cameras is probably more than 100,000 an hour, 50,000 an hour, like things that we'll never see in our career, that kind of thing. So normally, it's like a hammer hit it or something like that.
Yeah, external forces.
External forces, yeah.
So if we're talking about, and you're really, you're talking about how easy it is, but you're also talking about how powerful it is. So I think this kind of addresses our final myth that we're gonna talk about, is that 2D vision, it actually has its limitations. And for curveball, that's not actually a myth. That's rooted in truth. There's a lot of truth to that. And I'm gonna let Nick kind of start with that.
Yeah, so 2D limitations, and that's any robot guidance application, any vision guided robotics application comes back to mechanical design. And that's whether you're talking 2D, whether you're talking bin picking, I don't care what it is. If you don't have a good mechanical design, you're not going to solve that with software. And I think that's the same case on the robot side. you don't want to solve a mechanical issue with programming. It's just it makes a mess. And so that is a very valid assumption that 2D has its limitations, and you have to mechanically set up the application to support a 2D type of guidance, because the camera can only measure in one plane. It doesn't understand depth. It doesn't understand what this is. It just understands this plane. And so if your system is not able to support that, so your parts aren't sitting in a single layer, or maybe we're getting into parallax, which we're actually going to be able to show here in a minute, what parallax is. If you're getting into those type of issues, then it's just not going to work. And maybe you need to go to 3D, or maybe we need to go 2.5D, that kind of stuff, where it's going to be able to handle that depth consideration or anything like that. I'm not sure what you want to add to that, Ryan, in terms of a summary of that.
I think, as you kind of mentioned, the mechanical element of it is something to be aware of. And you kind of hinted at it at the beginning too, when we were talking about lighting. There are some products that lend themselves to 2D vision. There are other products that maybe we need to investigate different ways of doing things. And with the cost of 3D vision coming down so drastically, there are opportunities there. So I think we kind of put together kind of an interesting example here of one of the terms you mentioned, the parallax.
Yeah.
Understanding how the part shape can affect what we're looking at. So we've put together a little bit of a demo here. You can kind of see we've got rubber ducks is the shape we want to work with here. If I pull up the vision here, that's not. If I go run, here we go. So put that on screen. So in a standard application, right now I've got the rubber duck centered on the screen. When we located that, it was able to find it nice and easy.
Correct. Yeah, and that's it because that's how we trained it. So if we go back to our training here, we trained it in this location just about. That's where it knows. Oh, sorry, I'm on the wrong job here. There we go. Yeah, so it's very similar location. It knows what this shape looks like at this location. But now if we bring this image, and actually I think you can see it pretty well in this image even, this shape actually changes a little bit as you bring this item around to different areas, especially towards the corner of the image. And that's what we call parallax. And it's basically, if you think about looking down the center of a pipe, you actually see the walls of the pipe. And that's because just a visual effect. And it happens with our eyes, it happens with 2D vision, everything like that. And the issue it causes is because you're seeing and measuring a feature that is up here in this plane, and then that feature changes over here, your measurement's going to be off. You're going to have some shift on the robot side that you're not expecting to have happen. And so in 2D, that's a limitation. You can run into parallax, and you need to avoid that effect in order to have a good solution. And generally, that means, again, a planar part, that kind of stuff. This duck is definitely more of a 3D object that you might want to use.
Wanted to throw you a curveball just in case, but
yeah, exactly. And I don't know if you want to run the demo. We can kind of show what this looks like, so you can see it actually pick the duck here.
So we ran out of long cords on the camera, so apologize for the funky angle, but we'll kind of show you what's going on here. So in this case here, we've got a real simple application. I'm just identifying the duck, and I'm going to go pick it with the robot. So we'll reset our program here. We'll run that. And again, right now the duck is in the center of the grid, so it identifies it and is able to move to it quite nicely. So we're spot on the duck there. Should have switched that suction cup over.
vision system might not even identify it when I do this.
Yep. So we're going to loop it here. So we just took an image there. And in that case, if I pull up what the camera saw on the screen,
You gotta go to the run tab there.
go to the run tab.
It wasn't even able to locate the duct in this case. And again, that's because that head changed shape because of how we moved that and how parallax affected that. If I move it back in a little bit, and you can go ahead and try and locate, it'll locate it again. But now if you run the robot, what you'll see, we go ahead and run this robot again. What you're gonna see is it's not gonna hit it on the center of the head anymore.
I'll stop it so you can zoom in out the camera there to kind of see how it's hitting it.
Yeah, so now it's kind of off to the right a little bit, not quite where you'd want it right on center. So it might be a little hard to see with this camera, but you get the idea. And the reason for that is kind of twofold here. Again, it's what I'm calling parallax. And if we go back to the image of the Flock 2D here, what happens here, and if I can get this mouse, is when we take our alignment, the alignment that we did here was on top of the duck head. So that's actually where we took the millimeter to pixel, the pixel to millimeter translation is with this sitting on the top of the duck's head. But what we're actually finding is possibly, this is the beak of the duck. This could be, I don't know, probably 15 millimeters below the head. So the plane that we're measuring in versus the feature that we're seeing are in two slightly different planes. And as we move this duck around, it looks different because, again, of that effect where you're seeing the inside of a pipe. You're seeing the inside of this duck head here, that kind of thing. And that throws off the measurements. It's a slightly complicated topic, but it's what SICK helps partner on, and we help do applications engineering to make sure we don't get into those sort of things, or our distributors do that kind of stuff. So it's something very nuanced and a little, again, it's something that there is a limitation in 2D to what you can do when you get into this kind of stuff. The other limitations you might see in 2D can also be, again, just the plane. You have to have things on a plane. So you can't have them stacked. You can't have them, the duck can't be flipped over like this, and actually be flipped over and find like this, got to be up top. So things like that definitely have to be taken care of in 2D. And again, that's a mechanical setup. It's a design of the application. It's something that, again, Shibura can help with. It's something that SICK can help with to really understand that and help design a robust application in the end.
And a parting thought on this myth, not to knock on the truth. Yeah, sorry. The parting on this truth is, at the end of the day, the robot doesn't care. Not to knock vision, the robot doesn't care if it's 2D or 3D. The reality from the robot perspective is, as long as it has coordinates, it's going to do what it's told to do. So getting those clean coordinates is really what this myth is about, is understanding there are limitations and identifying what those limitations are, and accounting for them. And that's where people like Nick and myself come in to be able to help advise at the early stage of the game to make sure that you're not building yourself into a corner.
And that is definitely a good thing, good point to make on the last note here, is the early stage of the game. This is something that if you get right first, it never is a problem. And if you find it out after you've done your installation and everything, you're probably gonna be spending a lot of money to fix it. So it's one of those things that, get some consulting involved early from SICK or whoever you want to work with. Make sure they understand what you're trying to do on a very, high level, and they'll make sure you go down the right path. Have a partner. That's a great way to look at this. So.
And speaking of partners, we definitely want to thank Shibura for letting us come and use their awesome facility and their awesome bots and their awesome camera setup. I was telling Ryan, SICK needs this, so I might be getting a shopping list to take to my boss later on. But so we want to take a look at these robots in action, and our the SICK products as well. So let's throw up there where we can actually see these both of these products being used and everything coming up at some local trade shows.
Yeah, so we've got so this particular demo here that we've got on display here. We are actually going to be bringing this demo to the assembly show. So we've got some upcoming shows here with TM Robotics and Shibura Machine. Got that list up on the screen here now. So we're going to be doing some activity here over the next few months. This demo again will be at the assembly show. I know you guys have got some shows coming up here.
Yeah, we're both going to be busy this fall, Ryan. Yeah, we're looking forward to partnering with you guys and showcasing our combined solutions to give a better overall solution for customers coming up in assembly and a few other shows that you see there. So, so check those out and yeah, so thank you. So I'm gonna call it good. I've got my donut here. I'm ready. I'm ready for breakfast. I don't know what you got.
Yeah.
Good stuff right here. I'm loving this. So, Eric, I'm gonna throw it back to you while I eat. But yeah, take it away. Let's see if we got some questions here.
I was going to say you might be done, Brian, but I'm not sure Nick and Ryan are quite done yet. We do have a few
We're not off the
questions
hook
here.
yet.
Yeah, we do have a few questions that have come in from the audience. So let me just start off with the first one here. And it says, setting camera and coding inside the SCARA robot is easy, but on the camera side, it still needs to set the sending protocol to the target robot, including setup of the handshaking between the robot and camera. Is it easy enough for a new user so that they could handle the coding? No, it's kind of a long one.
Yeah, no, I can start with that. I think Ryan needs to jump in here on this as well. So how the Plot 2D camera communicates, there's three different methods. One is TCP/IP socket messaging, where we're just sending back and forth a bunch of comma separated strings or XML strings. Yeah, and so there's different ways of doing this. And then there's also the field bus protocols like Ethernet IP or Profinet. So those are available. Typically, though, what happens is when we partner with a robot company like Shibura, we create sample code, and that's something that we've been working on with Ryan. It generally will have a nice quick start guide. It will have just a nice sample that gets you from A to B. You know, a simple pick, trigger the vision, get the data in, pick apart, drop it off, and you can customize it from there for your application. So generally, the question here, when you say is it easy enough for new users to handle that don't like coding? Yes, I would say so, because there is a nice package that tells you exactly what to set. It tells you exactly how to get this going. It mostly is already done. You might just have to set the IP addresses, really, is I think the thing at the end of the day in terms of setup. I don't know on the robot side if you have any clients or anything you have to configure, or is it just IP addresses?
It's just IP addresses. So as Nick was talking here, I wanted to pull up. So talking about sample code, we put together a piece of sample code. So if you let us know that, hey, we're integrating a SICK camera on our Shibura machine robot, well, here's the sample code for you. Here's exactly how I've done it in the past. Right in the sample code, I actually list all of the different parameters that need to be set. So we talk about that. There's 4 of them, it looks like, that you need to set to configure to be specific for a SICK camera.
Yeah.
And once you're done, I show you what global variables you need to set up, and here's the program. Again, the program itself, we're looking at under 100 lines. The whole thing with all of the comments is under 120 lines of code, 130 lines of code.
Yeah, and there's a nice quick start guide that comes with it too. And it's something that once we're completely done and everything, we'll also probably make a video.
Oh, there's going to be lots of videos. Actually, TM Robotics, we set up a whole separate site, separate page on our website, tmrobotics.com/VGR, Vision Guided Robots.
Okay.
We're going to have a whole bunch of tutorial videos on there, exactly how all of this is going to work, all of the downloads. So making sure you've got all of the right grids and everything to download for calibration is all going to be there. All of our sample code will be there. And over the next week, while we've got all the nice, beautiful setup here for the webinar, we'll be actually recording a bunch of videos on calibration, and all of that's going to be on our page as well. So
exactly. So yeah, I would say it gets pretty darn easy when you start looking at it like that. Normally I know I'm more of a, experienced user, but normally when I go into somebody who hasn't done this before and we're working on it together, it takes, for Plot 2D, normally takes us a couple hours maximum to set up, and I'm just walking through with them. And when I hand it off and I'm not there, even then it only takes a couple hours. Maybe they take 3 or 4 instead of 1 or 2. because they're reading and going through those steps rather than me just teaching it out loud. But yeah, I definitely think it's an easier setup than especially than it used to be. So
Absolutely.
All right, great. Well, just a time check here. We have about 5 minutes left, but 2 more questions if you want to take a shot at these. I believe the first would be for Nick, and we talked a little bit about lighting, the cost of lighting, what might push you into 3D versus 2D. But the question is, how do you best determine if an application should be 2D or 3D?
so there's a lot of different factors in there. And I do see a question here about conveyor tracking, which might come into play here as well, answering this. And again, it comes back to what you're trying to do in the application. So there's different types of vision, like we started off with. You have static 2D, you have dynamic 2D, which is basically conveyor tracking, which is this other question that's in here. You have static 3D, you have dynamic 3D, maybe some hybrids, different ways of doing things. And how you determine what is needed is a couple different things. One is part presentation. Is the part coming down in a somewhat known orientation? So say like this duck, is it coming down head first, or could it be coming down like this too and all over the place in terms of how it's sitting? If it's just coming down head first, probably going to be 2D, as long as you can deal with the parallax issues.
Yeah.
Otherwise, 3D might be still the easier way to go. So there's always that piece of it. But if it's all over the place, you're definitely going 3D. And the other piece of it is always going to be how you need to place it. How accurately do you need to place it? How fast do you need to run? So that goes into conveyor tracking, where if you're sending something down a line, say in food, that at a meter per second,
Yeah.
that becomes difficult to image in 3D. There are some capabilities to do that and to do that well. We have solutions for that. But they have limitations because in 3D, often you're taking multiple images, or there has to be a grid that is displayed on it from a structured light point of view to actually get the point cloud, different things like that. And if something's moving underneath of it and you can't do it fast enough, that's a problem. And 2D works a little better in those cases. And that's where conveyor tracking comes in, where this thing's coming down on a conveyor and it's flying. The robot's got to go snatch it while it's in the robot's reach. And the Block 2D does support that. And conveyor tracking is pretty simple, actually.
And actually, I wanted to jump on that real quick. So this is the first and hopefully a series of webinars.
Yes.
So we are looking at doing a conveyor tracking webinar coming up here in the next few months. So the demo that we see here we'll be adapting over the next few months to test out and show some of these other capabilities. So stay tuned for future webinars involving conveyor tracking, some bin picking. We'll be doing some webinars on that over the next few months. So this is just the beginning.
Yeah, and so on that conveyor tracking question, looks like Damien posted here. Essentially, how conveyor tracking works is you just need to know the exposure. So when did the exposure occur? When did the camera take in the light to understand what's in front of it? And essentially what that does is when we know that, then the robot has an encoder attached to it, and the robot then knows how far that conveyor has moved since that exposure was taken. And so what the Block 2D does is it literally just has a digital output. That digital output hits the robot knows we took an exposure, and now it knows exactly where to start that conveyor tracking coordinate system. And your coordinate system for the Block 2D essentially just moves with the conveyor. And that's all it takes.
And on the robot side, we know that image was taken at this time.
Yep.
We know the conveyor is moving at this speed, so we can do the math internally. The end user doesn't need to worry about the math.
Exactly, yep.
We just need to know. And then there's on the robot side, we set a start line, if you will. As soon as that part crosses that line, we know it's now within our pick area. The robot can synchronize to the part, grab it, and go. And with the Shibura machine robots, we can track up to 1,000 pieces between the camera and the robot itself. So talking about the high-speed food applications, talking about applications where you've got a lot of parts moving fast or a lot of parts moving slow, but you've got a high volume of parts on the belt. Those are the kind of things that we can absolutely track. So we will be doing a video on that in the future, showing off some of those features and how that works.
There's actually a drop down in PLB and in Block 2D that does lanes for a conveyor. So you're always picking the thing that's furthest down the conveyor, because your robot has a reach. You can only reach so far. If it gets past the robot, you're not picking it. So you can always pick the thing that's furthest down the conveyor. Is a nice feature there. But Going back to the original question, 2D versus 3D, the major qualifiers really are, can you make a lighting scenario that's going to create a robust solution in 2D? Can you, are these parts coming down in a single layer fashion in a somewhat known orientation, or at least, you know, a stable orientation if you want to look at multiple locations, like an item that might just have two flat sides that are slightly different. Are they doing that? And that's okay too. Things like that. Can the 2D application support it? And if the 2D application, the limitations presented by 2D can't support it, then we're going to 3D. It's really, it's pretty simple to look at, is can those limitations that we talked about with 2D earlier, are they present and are they satisfied? Or if it's beyond the limitations, then we just jump to 3D. Yeah. So.
Okay, great. And I know we're running a little late, but I think this last question is something that our audience would be interested in hearing. That question is for Ryan, it sounds like. How do we know what kind of robot to use, 6-axis versus SCARA versus other?
I think it actually is a perfect segue from the previous question, 2D versus 3D. If we're working in a flat plane, so we're picking a flat part or even a textured part, but it's always in the same orientation and we don't need to come at it from an angle, SCARA robots are going to be fast, they're going to be quick, it's going to be nice and simple to integrate. If we're doing bin picking, also a future webinar, doing some bin picking, things like that, where we've got to be able to come at a part from an angle to pick it square so that when we drop the part, it's dropped in the correct orientation. That's where maybe a 6-axis robot's going to come in. So it really comes down to manipulation of the part itself. Is the part always going to stay in the same plane, or is the part going to go from one plane to another? That would be 2D versus 3D. From a robot perspective, that would be SCARA versus 6-axis. So in the simplest way to answer it, that would be the way to look at it.
Yeah, and I would say, you know, we can be a partner in this stuff. It's something that if somebody has an application, bring it to the two groups, we'll help you get to a solution. It's what we do every day.
Yep.
So.
All right, fantastic. Any final notes from either Nick or Ryan? I think we have everything covered.
I think we have everything covered. I see there was quite a good attendance. So if anybody has any questions, obviously reach out to Nick or myself. We're here for you guys. As a side little note, because we can do these kind of things, anybody who orders a robot from us between now and the end of the year that mentions this webinar is going to get an extra 5% off a list price. So little incentive for signing in and things like that. So keep a mind on that. And I know I've got a few distributors on here that just panicked when they heard that, but we'll sort it out. Don't worry. Yeah, thank you everybody for attending and taking time out of your day. I'm sure everybody's got busy schedules. So thank you for that. And
yeah, thank you everyone.